Kia ora, Year 9. Here come the last 4 equations from the lovely Don Steward task. If you haven't watched the first video, you might want to watch it first. I promise I'm going to keep this one shorter. But we were looking at these 10 equations in varying degrees of complicatedness. And in the first video, I got through the first 6 of them. So in this video, we're going to look at the really fun ones, which are these ones here, right? So they all look pretty hideous, but it turns out they're all really, really easy. So we're going to start with number 7, and everything we do is going to be backtracking. I'm not going to draw the bubble picture for all of them, but I will do it for a few. So I think that's number 7. Yep, here's number 7 coming up now. So let's do a bubble diagram for this one to get used to it again. We started with a number n, right? And what did we do to it? Well, let's have a look at this equation and see what happened to form that equation. We took our number n, and I'll just change my pen, and we divided it by 3. And that gave us n over 3. Then we added on 4. That gave me n over 3 plus 4. Then I took all of that, so I put it in brackets, and I timesed it by 2. And I got 2 times the stuff in brackets. Lastly, well, not quite lastly, then I added on, no, I didn't add on, I divided by 5. Right, and I got 2, it's not going to fit, 2 times that. I knew I would run out of space somewhere in here. That's all been divided by 5. And the very last thing that happened, which I have to do down here, is that I added on 3. So my whole expression looks really complicated, but it really unravels, right? It's like when you play pass the parcel as a kid. Let's just make it correct though. So we've got here 2 into n over 3 plus 4 divided by 5 plus 3. Okay, and that equals 7. So we're going to start the undoing now. So we can just about do it in our head, right? We start with 7, then we take away 3. So 7 take away 3 gives us 4. Then we times it by 5. 4 times 5 is 20. Then I take 20 and I divide it by 2. 20 divided by 2 equals 10. Next, I'm going to take away 4. 10 take away 4 is equal to 6. And what's left? I have to do the opposite of divide, and that's times. So I'm going to times by 3, and I get 6 times 3 equals 18. Now, I don't like that working because it's just a series of numbers. So what I'm going to do now is we're going to look at how we can do that using algebra. But basically what we're doing is we're backtracking. We're undoing every step. And when we started out, we went in this direction, whoosh, like that. So when we go backwards, we go in the opposite direction, doing the opposite operations, right? It's like a roller coaster going backwards. Yeah. Right, so now let's write out the algebra and see what we're going to do with it. We just have to remember the equation. Right, so it's 2 times n over 3 plus 4. Just have to check, divided by 5 plus 3 is equal to 7. I'm sure one of you is going to leave me a comment if I've got that wrong anyway. So let's undo algebraically. First, we're going to deal with the plus 3. So we've got 2 over n over 3 plus 4 divided by 5 is equal to 4. Now I times by 5. So 2 times n over 3 plus 4 is equal to 20. Now I divide by 2, right? And I'm left with n over 3 plus 4 is equal to 10. Now we subtract 4 and we have n over 3 is equal to 6. And finally, we times by 3 and we get n is equal to 18. So look at that. If you look up here when we did it with numbers, right, like as we probably would have before we knew anything about algebra, we got these numbers here. We got 4, 20, 10, 6, and 18. And you can see that structure coming through with the algebra. 4, 20, 10, 6, and 18. So the same stuff. Right, on to number 8. Now, number 8 I'm going to try and do with no bubble diagram. It's pretty similar in setup, but it's got a little bit of a difference. It's this minus sign is now on top of the fraction. So let's see what was the last thing to happen on the left-hand side. Well, the last thing that happened is that all of that numerator got divided by 8. So I'm going to start here by multiplying both sides by 8. This is what we get. Timesing both sides by 8, we get 16. Now we're going to add 4 to both sides. Right, so I've got this, I'm adding 4 to undo the take away 4, so we're keeping it balanced. Now I'm dividing both sides by 5, and I get 3n plus 4 divided by 7 is equal to 4. Right, so I'm dividing by 5 on both sides. Next, I'm going to multiply by 7, so I get 3n plus 4 is equal to 28. Same thing on both sides. So if you want to go back and draw the bubble diagram for this, go for it. But probably by now, you don't need to. So then we go 3n is equal to 24 because I'm going to subtract the plus 4. And now I'm going to divide by 8, and I get n is equal to, divide by 3 to undo the 3n, the 3 times n, and I'm going to get n is equal to 8. Now, what we should do, because it was such a messy equation, is we're going to go back to the start and we're going to put n in and check that it makes it a true statement. Whoops, I don't know what's happened there. Here we go. Let's see. So, if we now take this equation and we substitute in n equals 8, let's see if it works. So we've got 5 times, well, 3 times 8 plus 4 divided by 7, take away 4 divided by 8. So this is a really nice BEDMAS problem. Only I'm running out of space. No, I'm not. Magic, the magic of the tablet. I can just whoosh across like that. So first we work out what's in the brackets. So what have we got in here? Well, we've got 24 plus 4 divided by 7 minus 4 divided by 8. That gives me 5 times, right, this is basically in a bracket, right? This dividing sign is like having a bracket around these things there. I hope there's no maths teachers watching because this is pretty messy. So 28 divided by 7 is 4. So I've got 5 times 4 minus 4 divided by 8. And again, this line here is like putting a bracket around all of the top line. So now I've got 5 fours are 20. 20 take away 4 divided by 8, which gives me 16 divided by 8, which is 2. So did it make it into a true statement? Yes, it did, right? When n is 8 and we substitute all of that in, we can work out all of that stuff on the left-hand side, and it is indeed equal to 2. So we've now checked that our solution is correct. Okay, 2 left to go, and they're quite similar. So let's get into this one. We've got the equation there. The first thing that I'm going to do is subtract 6 from both sides. So we have 4 times 2n plus 5 over 7 minus 1 divided by 3 is equal to 9. Right, so I've subtracted 6 from both sides. Next, I'm going to multiply through by 3. And this is what I get. I get 27. I'm going to add 1 to both sides. And I'm going to get 28. Now I'm going to divide through both sides by 4, remembering that I could expand out, but here it's easier to divide through because 4 is a factor of 28. So that gives me 2n plus 5 over 7 is equal to 7. Multiplying by 7 gives me 2n plus 5 is 49. We're just about there, and you can see that it's getting easier and easier. Right? So this is like a 3-step equation. This is back to a baby 2-step equation. 2n is equal to 44. And lastly, I'll divide by 2, and I get n equals 22. Okay, so going through from here, I've times both sides by 7. I've subtracted 5 from both sides, and now I've divided by 2. And if you did a bubble diagram, you'd find that that all matched up with what I do when I'm working backwards like that, from the end back to the start. Okay, the very last one that I think when Year 9 see this, they kind of freak out and go, no, I can't solve that. Well, actually, you can. So for this one, I am going to do one massive bubble diagram. We started with n. I'm going to make my pen a bit skinnier. So we started with n in here. Right, what happened? Well, we times it by 3, and that gave us 3n. Then we took away 5, and we get 3n minus 5. We took all of that, and then we times it by 2. I don't even know how many steps this equation is going to have by the end, but it's going to have a lot. Now we took that, and we were still working with this top bit here, and now we're subtracting 8. Ooh, what a mess. 2 times 3n minus 5 minus 8. Now we're going to have to go around the corner. So we're taking that number and now we're dividing that by 6. If anyone's still watching, do let me know. I think you might have given up on me by now. Right, there we are. Divided by 6. I'm going to take that and I'm going to add 1 to it. What did I do here? Divided by 6. I'm going to add 1. Oh, I'm running out of space. 2 times 3n minus 5 minus 8 divided by 6 plus 1. Next, I'm going to multiply all of that by 7. I'm going to have 7 times, no I'm not, I've made a big mistake, haven't I? The 7 is what I do at the very end. So I've got all of that stuff inside the brackets. So where have I got up to? Well, I've done this bit, now I've got to add 1. Oh, that was close. Right, so we're going to add, hang on. Oh no, we've done the adding 1. I was right to start with, but I'm not remaking the video because this is already 11 minutes long. So we've got times by 7. So now we get 7 times 2 times 3n minus 5 minus 8 divided by 6 plus 1. And finally, I'm going to take that massive thing there and I'm going to subtract 4 from it. And that is my last step, and out pops my answer, which is 73. Okay, how many steps did I have? Let's count with the yellow pen. Right, 1 step, 2, 3, 4, 5, 6, 7, 8. Right, a couple of weeks ago you couldn't solve 2-step equations, well, most of you couldn't, and now you can solve an 8-step equation. So we're going to do this using algebra, and we're going to undo each side as we go. So let's do it. We've got 3 minutes until the video runs out. Can we do it? I don't know. Let's see. Right, the first thing I'm going to do is I'm going to add 4 to both sides. The good news is this equation is going to get easier the further through this I get. So that equals 77. Now I'm happy about that because 7 is going to divide into 77 easily. I'm going to divide both sides by 7, leaving me with this. So 77 divided by 7 is 11. Next, I'm going to look at that and say, well, I don't actually need these brackets now, so I'm magically going to erase my brackets. And now I'm going to subtract 1 from both sides. So it's getting better and better. 2 times 3n minus 5 minus 8 over 6 is equal to 10. And I'm going to multiply by 6 on both sides, giving me 60. I think we're through about 4 steps now, and it's getting better and better. Adding 8. 2 times 3n minus 5 is equal to 68. Oh, now I'm dividing by 2. I've got 3n minus 5 is equal to 34. 3n, adding 5 to both sides gives me 39. And ta-da, I get n equals 13. And now we've got 1.5 minutes left to check whether that works. So let's go all the way back up to the start. So let's see. Well, let's work from the inside out. 3 times 13 is 39. 39, take away 5, gives me the 34. 34 twos is 68. 68 take away 8 is 60. 60 divided by 6 is 10. 10 plus 1 is 11. 11 7s are 77. 77 take away 4 is 73. Yay, it worked. We didn't muck it up. Thank you for watching. You might like to try writing some more of these out for fun for yourselves and then swapping them in maths when we're doing revision. Let me know if you've got any questions on that. Remember, this method doesn't work as soon as we've got x's or n's on both sides of the equation, but it really works. Backtracking really works when we're starting out with algebra.